Now let's practice finding higher order derivatives. So let's find and simplify the second derivative for these following functions. So remember, to get to the second derivative, you first have to take find the first derivative, because remember, the second derivative is the derivative of the derivative. So let's first start out by finding f prime of x. So f prime of x, nice simple polynomial in this case. F of x is x to the fifth minus 5x cubed plus 3x squared. Fairly simple to do using the power rule. So derivative of x to the fifth is 5x to the fourth. Derivative minus the derivative of 5x cubed is 15x squared, plus the derivative of 3x squared is 6x. So we've got our first derivative. There really isn't anything we could do to simplify this other than factoring out an x. But because we're going to take the derivative of this anyways, if we were to factor that x out, we would have to do the product rule. So I'm not going to factor that out. I'm going to leave it in, leave this as this polynomial to make our life easier. So f double prime of x now, the derivative of our derivative, so it's the derivative of 5x to the fourth minus 15x squared plus 6x. And so in that case, derivative of 5x to the fourth, remember, multiply 5 times our power 4, so that's 20. X to the third power minus derivative of 15x squared, so 15 times 2 is 30, x to the 2 minus 1, or 30x to the first power, and the derivative of 6x is just 6. And we're done. Now if you wanted to, you could technically pull out a 2 from this, but there's not a real big need to, so I would just leave it as this. Alright, next one. So y equals x plus 3 over x minus 5. So again, first step we've got to do is find y prime. So y prime is equal to low d high, so now we're using the quotient rule. So the denominator, x minus 5, times the derivative of our numerator, 1, minus high d low, so minus x plus 3, times derivative of x minus 5 is 1, all over x minus 5 quantity squared. Simplifying this, that gives you x minus 5 minus x minus 3 over x minus 5 quantity squared. So the x minus x is 0, so we don't worry about that. So minus 5 minus 3, so we end up with the first derivative is negative 8 over x minus 5 quantity squared. So normally I would say leave your derivative in this form. I would say this is the first derivative and be done with that. But we need to take a second derivative. Now we're going to get a rule in the next section. You're going to have a rule called the chain rule that's going to let you rewrite this and then differentiate it fairly simply. But in this case, we don't have that rule yet. You can't use that rule yet because you haven't learned that rule yet. So we need to take this one more step. We need to go ahead in this case and multiply out our denominator so that we can then differentiate using the quotient rule. So let's multiply out x minus 5 squared, so that's x squared minus 10x plus 25 for our derivative. So now let's differentiate this. So y double prime now, we've got to use the quotient rule again, at least for the time being. So low d high, so x squared minus 10x plus 25 times the derivative of negative 8, which is 0. Why? That's right, because negative 8 is a constant, right? So the derivative of any constant is 0. Minus high d low, so minus negative 8 times the derivative of x squared minus 10x plus 25, which is 2x minus 10, all over our denominator, which is x minus 5 to the fourth. Now I'm doing a little trick here, right? So remember, when we wrote it out in the expanded form, x squared minus 10x plus 25, that's still x minus 5 squared, right? So what I did is I just used that nice simplified version so that I don't have to sit there and say it's x squared minus 10x plus 25 quantity squared, right? When we already know that that denominator, x squared minus 10x plus 25, is x minus 5 squared. So really, this is just x minus 5 squared, and anything that's squared twice is just to the fourth power, right? So using our exponent properties there. So that's a nice little trick, just saves me from having to write all that out again. And especially when we're going to try to simplify this, you're going to have to factor it back out anyways. So why not go ahead and save some time and do that? So let's clean this up. Well, that's really nice in the first piece, right? It's this quadratic equation times 0, right? Anything times 0 is 0, so that goes away. So then we have minus negative 8, so that's going to be plus 8 times 2x minus 10. Now, looking at 2x minus 10, does that look like you might be able to simplify that a little bit? Yeah. Let's factor out the 2 and see what happens. So if I factor the 2 out of 2x minus 10, that leaves me with x minus 5 in the numerator, right? So I've got 8 times 2 times x minus 5 over x minus 5 to the fourth power. So now I can simplify that a little bit. So I end up with the second derivative is 16 over x minus 5 to the third power, canceling out one of those x minus 5s. And that is the second derivative of this function. All right, let's look at one more example of finding the second derivative. So h of t is equal to e to the t sine t. So in this one, we've got to use the product rule first to find the first derivative, right? So h prime of t is equal to the first e to the t times the derivative of sine t, which we know is cosine t, plus the second now, so sine t, times the derivative of e to the t, which is e to the t. And so we get e to the t cosine t plus e to the t sine t. So you have a choice now. We have the first derivative. Now you can either leave this like it is and do two different product rules here to find the second derivative, or I'm going to do something we would normally do anyways to simplify this. I'm going to factor out my common e to the t. So if I do that, I end up with e to the t times cosine t plus sine t. And how did that help us? Notice now, if we want to, so we know we're going to take the second derivative, but what's going to happen? We're only going to have to do one product rule instead of two. So it just saves us a little bit of effort. So let's find the second derivative now. So h double prime of t. So first function, so e to the t, times derivative of the second, so derivative of cosine t plus sine t. Well, cosine, that we use the sum rule, right? So the derivative of cosine t is negative sine t plus the derivative of sine t now, which is cosine t. So that's first times derivative of the second, the first half of the product rule. Now plus the second times derivative of the first. So plus cosine t plus sine t. So that stays the same now, times derivative of e to the t, which is e to the t. Let's clean this up a little bit. So to clean this up, I'm going to actually rewrite this, right? So I'm going to multiply through the e to the t's. You could also factor the e to the t out. Well, let's do it that way. Let's see what happens. So if I factor the e to the t out, then that leaves me with cosine t minus sine t plus cosine t plus sine t. The sine t's cancel each other out. And so I'm left with 2 cosine t. So cosine t plus cosine t, you have 2 of the cosine t's, e to the t. And we're done. Now, you could, to clean this up, make it look nicer and to avoid confusion, you could write this, and I probably would. I'd write it as 2e to the t cosine t. But that's the only other thing you really could do to this. But then you're done either way. So let's do one more. Let's find and simplify the third derivative for f of x equals 2 over 3x to the fourth. So this one looks like you might want to try using the quotient rule at first. I encourage you to resist that urge. If you use the quotient rule on this, you're going to make your life a whole lot harder than it has to be, right? Why? We only have one thing that has an x in it, and it's just an x to the fourth in the denominator. So let's rewrite this like we've done before. So rewrite this as 2/3 x to the negative fourth power. Well, now, didn't that make that a whole lot easier? Now let's find the derivative by using the power rule, right? So power rule versus quotient rule. I'm going to go to the power rule every time, right? Because it's easier. So f prime of x then is going to be 2/3 times -4, right? So remember, bring the power down, multiply it by your coefficient. So -4 times 2/3 gives you -8/3. X to the -4 minus 1, so -5th power. And if we were working on simplifying this, we would rewrite this first derivative as -8 over 3x to the 5th. But I actually want to leave it as the -8/3 x to the -5th because what are we doing next? We've got to take the second derivative, right? So to get to the third derivative, you've got to go through the first and second derivatives of this. So the second derivative then, same idea. So multiply now the -8/3 times -5. So we get positive 40/3 x to the -6 because we're subtracting 1 from our exponent again. Same idea, rewriting this, 40 over 3x to the 6th. And one more time now to get to the third derivative. So f triple prime of x is equal to, now same idea, so 40/3 times -6. X to the -7th. Now the reason I went ahead and wrote this out makes it a little bit easier to see. We can cancel before we do the actual multiplication, right? Why would you want to multiply 6 times 40 and then divide by 3? Let's go ahead and simplify it before we cancel. So 3 goes into 6 2 times, right? So then that just gives us -80 x to the -7th power, which then ends up being -80 over x to the 7th when we rewrite it. And that is your third derivative.